Our third speaker is Steve Gates, who's the chair of Sustainable Energy Now, who I gave a little shout out to before, who are doing wonderful things in the renewable energy advocacy space here in WA. Steve, please welcome.
Thanks, Scott. Yes, well, as Scott was saying, actually we started up about 3 years ago. We're passionate about promoting renewable energy, and we've gone about that in a number of ways. We're essentially made up of a group of people from all walks of life, including technical backgrounds in economics, marketing, and so on. And we started off with by doing research into the renewable energy technologies and the renewable energy resources that we have right here in WA. And our focus is on the Southwest Interconnected System that's our electricity grid here. We then collated all that information and started working on the promotion side of things. And our audience is to the general public. You may wonder how we fit with what used to be West Australian Sustainable Energy Association, is now Ray Will's Sustainable Energy Association of Australia. Because we're a volunteer organization, our target is the grassroots, or the general public, education and so on. So we've moved into that area, and we work complementary to SEA. So our promotion has been focused on the general public. However, we have actually had audience with industry, and we've met with industry engineers and so on to talk about our simulation and various other things I'll get to shortly. We've also developed an education package that's gone to we worked with the Science Teachers Association of WA and the Curriculum Council, and so that as a result of that, we have a Year 12 integrated science package we've created, and we're working on refining that right now with those organizations. And the last, but probably the most significant thing in terms of getting interest from government and industry is the simulation. With the technical background of our tech team and economics team, we put together what you can see here on the top right, a screenshot of a computer simulation that uses essentially engineering models overlaid onto the map of WA there. You can put various types of renewable energy generators, wind wave, solar, geothermal, and so on, biomass. And wherever you put it, it takes account of what the renewable resources are at that location. So it generates, literally it generates virtually an amount of power that would be coming out of that power station on a seasonal average. And we then, as you can see on the right side of that, we have a 24-hour versus power demand curve that you can see, the black line. And you can see how renewables are, in this particular scenario displacing the fossil generation there. We have had interesting discussions with Verve Energy, Western Power, and so on, and generally they've been very helpful in helping us develop this. And just out of a bit of interest, most people want to know how big these things would be, and we've got the ability to export some of the information to Google Earth there on the bottom left. And for example, that would be roughly the size of a 400 megawatt solar thermal station superimposed on land that could potentially have other uses, particularly if wind, of course, you've got double use, and lots of benefits for some of the outlying areas of the wheat belt that are now becoming affected by climate change, drying, and so those communities can reap benefits from renewables as well. And the last thing we've just completed is what we call Renewable Energy Scenarios for West Australia, a discussion paper, bottom right there. And the goal of this, on a few requests from various people, was to create various scenarios that could be roughly costed and visualized. This one's a 30% by 2020. Doesn't mean that we could only reach 30%, it's just a model that was chosen that was better than 20% and kind of in line with, I believe it's South Australia and California. So you can see the colored dots there correlate to different types of renewables, and on the left you can see the amount of energy that would be generated in 2020 compared with 2010. Down below on the lower left you can see the installed capacities of the various types of renewables. And in developing this, again, we've met with the various industries, and we would like to acknowledge their very helpful input to it. It doesn't mean that they necessarily endorse it. It's the same as planned, but they've certainly been very helpful. I'll just move really quickly through here. This is the an 80 to 100% renewable scenario. We've got a date on it as 2050, not because it would take that long necessarily to get there, but that we're looking at the amount of energy that would be required, and you're looking at about 3 times the present energy if we grow at the rate that's presently projected. None of these models take into account any carbon pricing either, and they don't take into account gains by energy efficiency and waste reduction. So they're very conservative in a lot of ways. So thank you for that.